Okay, so for these last few problems in example 3, again, more wordy as far as how they're presented. So we're going to try to tackle them a certain way and see if it hopefully jives with your way of thinking. Now, there's more than one way to tackle these problems. So if you don't tackle it the exact same way that I do, that's fine. But make sure you evidence how you're solving your problem and don't just give me the answer because I don't like to see just the answer. So, all right, so let's start off with this one. We got Ricardo gained 15 pounds over the winter. He went on a diet and he lost 28 pounds. Then he regained 5 pounds and only weighed 177 pounds. How much did he weigh originally? All right, well, so like I said, there's a couple of ways that you can tackle this. You can kind of reverse engineer this problem if you wanted to and eventually get to your answer. Or you can use a more algebraic approach, which is the way we're going to do it. So the first thing we need to do is kind of give a sense of what his original weight is originally. We don't have a value for that or anything. That's what we're trying to find. So let's let x equal that. So Ricardo's original weight. So now we have a value for that, x. So let's kind of describe what happened to his weight over time. So we first start out with his original weight, x, and then what happened to it. Initially, he gained 15 pounds. So we're going to want to add 15 to that. So that takes care of the 15-pound gain. And then he went on a diet and he lost 28 pounds. So we're going to lose from that point, we're going to lose another 28 pounds. But then he regained 5 pounds. So we're going to add 5 to that. And then he only weighed 177 pounds at the end of all that. So at the beginning he weighed X, he went through these different ups and downs, and then he ended up equaling 177 pounds. So that's the way I would, suggest you or tackle it that way. But again, it's not the only way. As long as you can evidence it with some math, then that would be acceptable as well. So now for our next steps, we got a lot of like terms on here. We have a lot of constants that we can combine. So let's do that. So we got 15 minus 28 would be negative 13. So negative 13 and a positive 5 would give us a negative 8. So we got x minus 8 equals 177. And so if we add 8 to both sides, so we get x equals 185. Now the nice thing about these problems is that if you use a let statement like this, which I would recommend, you can put your answer up next to it. So Ricardo's original weight was equal to 185 pounds. And of course you could use the abbreviation, which is LBS. So that would be fine too. And there's your answer. All right, let's try the next couple. A college bookstore ordered 6 boxes of red pens. The store sold 32 red pens last week and 35 red pens this week. 5 pens were left on the shelf. How many pens were in each box? So, same idea as the previous one. Let's give a variable to describe how many pens were in each box. So we'll let x equal the number of red pens in each, not each box, but each box. All right, so there's that. So now let's start from the beginning again. So the college ordered 6 boxes of red pens. So x is the number in one box, each box. So if we want to describe 6 boxes, we would need 6x. So there's our 6 boxes. But what happened? The store sold 32 red pens last week, and they sold another 35 red pens this week. So each time you're losing pens. So we lost 32, then we lost 35, and then what happened at the end? 5 pens were left on the shelf. So after we ordered the 6 boxes and we sold all these pens, we were left with, we were equal to 5 pens. So that should be your equation for this one. So same as before, we got some constants we can combine. So 6x minus 67 equals 5. And now we can solve for x. We can add 67 to both sides. So we equal to 72. And if we divide by 6, so x equals 12. So number of red pens in each box, so 12 red pens. And if you want to say per box. But that should be it. All right, let's try the last one, and that will wrap up 3.3. So Paige bought 5 bags of candy for Halloween. 48 children visited her home, and she gave each child 3 pieces of candy. At the end of the night, she still had 1 bag of candy. How many pieces of candy were in each bag? So again, the question kind of helps us frame what x is. So we're going to want to let x equal the number of pieces in each bag. Now, you could be really descriptive and say pieces of candy in each bag, but we know what we're talking about. So x is the number of pieces in 1 bag of candy. But she bought 5 bags. So that's the starting point. So 5x. And then what happened? She started giving it away. So there was 48 children, and she gave each child 3 pieces. So how would we kind of bring that together to describe how much candy she actually gave away? We just multiply, right? So yeah, let's just multiply 48 times 3. 48 children, 3 pieces per child, so that will give us how much candy she gave away. At the end of the night, she still had 1 bag of candy. So would we just say this is equal to 1? No, I'm not going to say 1, because then it would be like 1 piece of candy left. She had 1 whole bag left. So remember, 1 bag is x. So it's going to be a 1x on that side. All right, so this frames the whole situation. How much she started with, how much did she end with? And so now let's just break it down. So let's take care of this multiplication first. So that's going to be equal to 144. And now we can start getting the x's to one side. Now you might be tempted to want to subtract 1x over to this side, but then you're offloading everything onto one side, which can be a little problematic. So I would recommend instead, since we got just numbers on the left, let's move all the x's to the right, which kind of goes against what we've said before, but as long as you're careful, you should be okay. So the 5x's cancel, so we got this negative 144 equals 1 minus 5, which is equal to a minus 4x. So that should be on your right side. And so now the last step is get rid of that negative 4. So don't forget the negative, because now you can see what happens. It's going to become positive, and we got to have a positive answer. We can't have negative candy. Who wants negative candy? So cross those out. So x is equal to 144 divided by 4, which I didn't divide, but I'm pretty sure that that's 36. So that finishes it off. We need 36 pieces per bag. And that is that. All right, so now we're going to be going into 3.4, which we'll see in the next video. So stay tuned for that.